Hello everybody, in this video we are going to discuss the different agent orchestration frameworks that you can bring and use on Databricks. And then we're going to go and deep dive into a financial services agent. So we have Sarbani today with us. So Sarbani, can you introduce a bit yourself?
Sure. Thank you, Maria. Thank you, Lara. So I'm Sarbani. I'm working as ML Specialist Solution Architect in Databricks as part of India team. I'm based out of Bangalore. And I am here to talk about Databricks Agent Framework. How are you going to help the customers with different agentic patterns and all?
Amazing, thanks. So can you describe a little bit the use case we are solving today?
Sure. So today's use case, I'm going to show how to build a financial analyst AI assistant agent, which is going to help us with some financial calculations. As you know, there are a lot of calculations happen in the financial world. So I would like to show, there are some simple calculations, but it can be complicated as well. All this calculation is going to use the Python executable, so that Python as a code will help to do all the math calculations. Also, I'm going to use the same agent to extract the data from emails. So a lot of time customers notify the bank whether a particular transaction is fraudulent or the customer transaction is legitimate, even if there is a high value transaction is happening. So the agent will be able to scan through all the emails and it will be able to tell us if there is any important communications coming from that particular customer. So these are just two examples, but possibilities are we can also add a lot of other functionalities using the same framework. It's a reusable framework and we can keep on adding different functions. And I'm going to use the Databricks Mosaic AI agent framework to build this agent.
We hear about other frameworks like LangChain, LangGraph, AutoGen, Semantic Kernel. So what are all of the different orchestration frameworks and can you explain them a bit?
Sure. So LangChain is a framework which is going to help us to build different agent. As we know, the agent means there is a LLM, and LLM will be able to use or access different tools. It can be a SQL function, it can be a Python function, it can be a API call to the external world, or within the internal world, it can be it can connect to the enterprise data as well. Is a form of structured data. So this agent, when it is built, it has to be it has to connect with other different components which are part of our LLM ops pipeline, you can see. So like how to connect to the structured database, how to connect to the unstructured data where my entire unstructured knowledge base is sitting. So LangChain is a framework which is going to help us to build this entire chain network. Now LangGraph comes into picture when we are talking about a typical multi-chain, multi-agent network. So this is going to help us to build a graphical interface. Like we can literally see the nodes, which are actually agent, and that can have the state of the agent, and then we can build all the edges. Let's say there is a supervisor agent, and then the supervisor or router agent can route the request based on the query type. So let's say it's an order query, so it will go to the order agent. Let's say somebody is asking to register for a particular service, so it will go to the service agent. So that way we can design the entire workflow in the form of a graph, and LangGraph is super useful and it can help us to build this end to end. So generally LangChain and LangGraph are used together to build this entire agentic architecture. It can be single agent or it can be multi-agent, then multi-turned conversations can be built on top of that. Now AutoGen.
So LangChain is one agent, whereas LangGraph is multi-agent.
Multi-agent, right. So within the LangGraph, I can create multiple agent, different nodes, and then I can design the complex architecture. And there are different architecture on this LangGraph, like supervisor, as I said, collaborative architecture. So different kind of multi-agent patterns are there. And if you're talking about, like, as you mentioned, AutoZen or Semantic Kernel, so there are some Microsoft product as well. Now, they are also agentic framework. The difference is that LangChain, LangGraph is kind of helping us to build a production-ready agentic framework quickly because it has all the different libraries and components available so that we can quickly integrate with other components of the entire architecture. In AutoGen and Semantic, as they are part of the Microsoft ecosystem, so there are certain limitations, and sometimes it mostly works with the Microsoft, let's say the team search or the SharePoint kind of documents. And in LangChain, LangGraph, what we have seen is they have tons of examples and tons of libraries are mostly they upgrade the libraries as and when the new releases are coming up with different models and different integration. Especially with the Databricks, we do have a fantastic integration with LangChain and LangGraph, and mostly our recommended architecture is based on LangChain, LangGraph, though there are other patterns are available like OpenAI and OpenPython agent as well.
Okay, sounds good. So if we take a step back, so I just would like to understand the difference between how to build agents on Databricks and what are the different authoring patterns for agents in Databricks versus that. Is Databricks then a different way of doing this compared to LangChain or LangGraph? I think I get this question a lot from customer because they say, oh, I don't know if I want to use the Databricks agent framework. I want to use LangChain, LangGraph, semantic kernel, and then we have to clarify that maybe the choice of word was not the best to say Databricks agent framework, that we're actually not an orchestration framework, that we're not a competitor to those ones. You can use them on Databricks. Am I right in understanding that?
Yes, yes. So Databricks is not stopping you to use your own agentic framework versus LangChain, LangGraph, nothing. So Databricks is going to give you the platform where you can build your agent from the scratch, and you can integrate with different Databricks components which are part of Databricks LLM Ops ecosystem. Let's take an example. Let's say you want to build LangChain, LangGraph. So you might have already built a LangChain, LangGraph code. You can easily import that code in Databricks. Only thing you have to include one abstraction layer or library, you can say, which is one authoring pattern, which is Databricks LangChain. So Databricks -LangChain is one open source library which is already available. You can just import that, and with this library, you will be able to access all the Databricks component which can interact with LangChain. Let's say your LangChain agent, you want to create all the functions and tools in Unity Catalog, because this is our governance layer, correct? Once you create all the function in Unity Catalog, you don't have to think about governance, security, as a different component. It's already there. Now, once you register the function, our code should know that my functions and toolkits are sitting in Unity Catalog function tab. So that integration, it's already there through Databricks LangChain library. I don't have to add any single line. I can directly go and call that particular function by using UC function toolkit. So UC function toolkit is already available in Databricks LangChain library.
So
this is one example.
There, just to clarify, that means if I have developed an agent using LangChain somewhere else, I can port that code into Databricks without issues, right?
Yeah. So we have to just see all this connectivity, like we have to import Databricks, as I said, Databricks LangChain, and then I can start using the UC function toolkit. Now, let's say as per your architecture, you are saying, no, I don't want to use UC function toolkit. I want to use it outside that. That too is allowed within the Databricks node, because here there are two things we can say. You can build your tool within the UC function toolkit, or you can build your function outside UC function toolkit. Let's take one example, vector search. But let's say vector search is part of Databricks. You have created your knowledge base and you have created vector search retriever tool through which you can extract the similar content from your knowledge base, and you want to use it for your agent as a tool. So that too can be possible. Then you don't have to use UC function toolkit. You can just use vector retriever tool. That is another method, is already available in LangChain Databricks library. You can call that function, which will give you the capability to call the tool outside UC function tool. Let's another example, Genie. Through Genie, you can talk to your structured data easily. But again, Genie is not a UC function toolkit, but Genie, we use Genie as an agent. So that Genie as an agent can be part of your toolkit through that Genie related. There is one Genie function available through. You just need to call that, and you can start using Genie as your agent. We don't call Genie a tool. Genie is an agent, but it can be a tool for your agent as well. So that way you can easily interact with Databricks LLM ops and LLM offering and different components within the LangChain LangGraph. Same code, and there is no change.
Can you show us the code?
Sure. Let me share my screen.
Yeah, and also just to add while you're sharing your screen, that the great thing about UC function is that when it integrates with your global governance model, that means all the permissions are assigned to groups will trigger down to this particular function, which means that you will not be able to use functions as a user that you should not have access to, which means the security aspect is covered. And that's very important because sometimes that's what can block people from going to production.
Yes, definitely. So here is a code notebook where I have implemented a LangGraph agent using our Mosaic AI agent framework. This is the Databricks Mosaic AI agent framework, and here is the different components which are used here. As I said, the LangGraph agent is going to use the UC function toolkit, and it is also being wrapped with chat agent with custom input and output. Let me explain a bit. So the agent is built using this notebook, and after that agent will be registered in unity function as a model. Now this model is part of MLflow. MLflow is already integrated with Databricks, where we can register our model or agent, and through MLflow we can also create our agent serving endpoint. Now when we register any agent in MLflow, there are various interfaces are available. So one of them here we are using here chat agent. So this is the most recommended MLflow interface what Databricks is recommending, because within the chat agent interface we can easily integrate the custom input output, which is let's say when we are talking to the agent, sometimes we need to pass certain parameter as an input to the request, let's say customer ID or session ID, and we also need to extract some information as part of the agent response, which are not part of the agent conversation history, or we don't need to maintain history of those, but these parameters are useful when we are talking to the agent in request and response format. For this kind of custom input output are already available within this chat agent interface. And MLflow chat agent will help you to wrap the entire agent as a code, and then we can register it in MLflow. So here one approach will be used, which is called model as a code. So basically what we are going to do, we'll create the entire agent code here in this particular notebook in one particular cell using the magic command. And once this driver notebook will be run, the agent code will be created and it will be used by the driver code, and automatically it will generate the agent, it will register, and finally it will create the model serving or agent serving endpoint. Okay, so here we are going to use a tool calling. So now the name is kind of coming up as tool calling LangGraph agent wrapped with chat agent with custom input and outputs. So these are the major functionalities which will be integrated here. That is the technical approach. And as we are talking about, it's a business and domain expert AI assistant. Like it's going to help the financial operations or operation team as a financial analyst, which is going to calculate different financial calculations, or if I need to check any email from the customer, that can be done by using a RAG approach. Now important here, so how to use the LangGraph Databricks interface. So here you can see the LangChain Databricks. So this is the LangChain, this is the LangGraph, a particular version is used here. And then you can see Unity Catalog LangChain. So this is a Databricks interface used here. Databricks LangChain is the main interface through which Databricks and LangChain both can interact with each other, and different Databricks libraries will be available in the LangChain LangGraph framework.
Awesome.
Then this is done. Okay, so now here, as I was talking about, define the agent in a code. So we are going to create the code within this particular notebook, and then the separate agent code will be created once I'll run it. So how it is done, let's see. So before that, I'll just, I was trying to talking about this part, correct? The LangGraph agent. So the chat agent interface, this is a part of MLflow. And the nice thing is that this is nothing, specific to Databricks. This is a open source and it's a part of MLflow. So anybody can go and just use that MLflow chat agent interface.
That's a very good point to highlight that,
Yeah.
you're not locked in when you build that on Databricks, that it's
Right.
open
Right.
source.
So these all are
This,
MLflow interface
sorry,
and
sorry,
open source.
Stefani. So this chat agent MLflow is an MLflow flavor, right? So
Right.
yeah,
Right.
got it.
And there are two different APIs are used, chat agent state and chat agent tool node. And these two nodes are going to help us to interact with the LangGraph architecture, because in LangGraph we need to build the node and we need to build the agent and agent state. There are some advanced capabilities are there. So streaming output. So we'll see when the agent code is developed, in the predict method, we'll have two different functions. One is predict, another is predict stream. So predict stream will give us the capability to interact with the agent in a request response format, and it will use this streaming method to continuous converse with the agent. Then it is also going to help us some typical agent and MLflow requirement, like the authoring interface, then signature. In MLflow, if we need to register the model, we need to create the signature. That can be done smoothly. We don't have to do anything else because it's a part of MLflow interface only.
Can
AI
you
gateway
clarify
can
to
be.
people watching what signature means in that case?
Yeah, so in the chat agent signature, one see it will automatically infer the signature from the chat agent which is going to be built. So here we are going to use MLflow and chat agent particular flavor. So that chat flavor is automatically help MLflow to understand the signature of this particular model. So like if the flavor is not compatible with the MLflow flavor, generally we need to create the signature by providing the input, and we need to create the output by using another predict function. But here we don't have to do that. MLflow will automatically understand what is the signature coming from this particular chat agent. It's a kind of a flavor is compatible. We can say that this particular flavor is compatible with the MLflow. So we don't have to build the signature outside this function.
Very powerful.
And custom input output, as I was talking about. So we can build the custom input with the request, and we can also extract the custom output along with the response. And the same thing is available on our review app and the playground. So here we are going to use the code, but in the review app and playground setting, we can set the custom input output as a JSON formatted small script.
So like these custom inputs, outputs will result in a custom signature then.
Exactly.
Yeah.
And these are the functions are going to be used. So let's look at the code here. As you see, model as a code or agent as a code approach means we are going to write the entire code here in this particular cell using this magic command. And this is the agent.py which will be created once this particular cell will be run. And as part of that, these are the typical libraries will be loaded. And this is our Databricks LangChain UC AI interface, the first interface where it's going to interact with the Unity catalog. Then chat Databricks.
So what we mean by that is when we execute this cell, another script agent.py will be created on the directory.
Right.
That is the real code that we're going to deploy.
Right. So like I'll show you. So as you see, this agent.py, this was created once I ran it. So it was not there earlier. The moment I run this particular cell, this particular code agent.py will be created, and every time it's in overwrite mode. So if I need to change anything, I'll run it again and it will be created and it will overwrite the previous file. So anytime I can go back and see what is happening in the agent code. Okay, so this agent.py is needed because we want to pass the entire agent to MLflow so that we can register that. So this is actually driver code. The notebook, this LangGraph custom schema is kind of, you can treat it as a driver notebook. Actual agent which is going to be registered in MLflow, that's this one, agent.py. And MLflow, in MLflow, there is a way we can pass the entire code because that is going to give us a lot of flexibility. So let's say, as we know that MLflow has a lot of flavors, as you said. So let's say MLflow.langchain is one flavor, MLflow.python is one flavor, and there are various flavors are available. But if I want to use the particular flavor, I'll be restricted because I'll be able to use some libraries. Maybe there is some library conflict. And nowadays, as you have seen, we are heavily dependent on the open source ecosystem. And every year and there, let's say LangGraph has released something, maybe Databricks has not yet released, so there will be a version mismatch, we have to lock something. Uh, so to come out of this particular fixed template or format, we are giving a lot of flexibility to the customer so that you can build anything as a code within the agent. As even Lara was saying, correct, some customers want to build something in Python, open Python, they don't want to use anything, they can build their own agent from scratch, they can build that. Then it will not be the typical MLflow flavor. Now you can say, yes, MLflow has another flavor, PyFunk. This is what we are going to use here. So PyFunk is really good. PyFunk is going to help us to wrap any custom model, so which is not part of MLflow listed flavor, that can be built as part of MLflow.pyfunk function, which is a custom Python.
So anything
But
not supported out of the box through
exactly,
MLflow, you wrap it
exactly.
into a Python mainly.
PyFunk. But with LLM, with different kind of LLM libraries coming into picture, lot of time we have seen there are a lot of messy codes are required in order to create a PyFunk code and register it typical MLflow.pyfunk, like the way we generally do in typical standard DSML code. So in LLM, we have seen a lot of mismatch. Like sometimes schema output schema is not matching with the LLM output. The way LLM is generating the response is not accepted by the, let's say, the model serving endpoint. To avoid this kind of issues, so there is a chat agent. First of all, chat agent has just come up as part of MLflow LLM ops offering. And along with this model as a code is used, which is going to give us a lot of flexibility. Like I can actually build anything inside the agent code. If I need to take care of structured output, if I need to take care of different schema, if I need to take care of different tooling system, if I need to create some tools which where I need a support from OpenAI interface as well. Because here right now I'm showing the tools which are sitting in Databricks Unity Catalog, but a lot of people are using some function calling offering from OpenAI as well. So to support different kind of ecosystem, this model as a code is extremely helpful. Then I can just build the code, and driver will create the agent, and then I'll show you how you can just need to pass the entry path of this particular agent, and it will be logged in MLflow just as a code. Everything will be wrapped and put it inside the MLflow.
So if I understand, you want to log the agent so that then you can iterate as part of your LLM ops,
Exactly, absolutely,
So
absolutely.
that
And
you
this
can
is extremely
iterate,
helpful.
yeah, okay. Just like you would do for any ML, traditional ML model in the end. Yeah.
Yeah,
Okay.
yeah, yeah. So the only this built-in pattern is bit different. This authoring pattern is bit different. Otherwise, it's the same the way you use the MLflow. So now, as you see here, the auto log is automatically log everything, and we are creating our Databricks function client. So this is our main client will be created. And now the same way, the way you can create your LLM endpoint, the chat Databricks will be used to call this particular client will be used to call the LLM endpoint here. Here you can see I'm building my system prompt. So this is again based on your use case, you build your system prompt. And now the important part is the tooling part. So tool first will create the list, empty list. And here you can see there are two ways I am using the tool. One is the UC function toolkit. So here I am passing my entire UC tool names. Sure. So now here I am using one tool which is already available in our system catalog. So that Python executable, it is already available for any workspace. You can just go and grab it where you can execute any Python code. And then I am using another tool which is not part of UC function toolkit, but I am using vector search retriever tool. As you see, the particular code is already giving me that template. I just overwrite this particular template with my vector search retriever tool with my index. This index is created using all the emails, and then I created an index on top of the email content, and the ID is passed.
Here you already created your vector index, right?
Right. Yeah, vector index is already created by using the typical,
Yeah.
index creation process. You
Yeah.
can use UI or you can use the
Yeah.
vector search code as well.
So good point. So
Uh,
to wrap all of this together, you need to have built all your tools beforehand, right? So
Right,
tools you
right,
define before,
right.
and the vector sets need to be pre-built, and then now you come and wrap them together.
Exactly, exactly. So tooling function, create function or create tools are kind of first activities we should do, and then we'll start linking all the tools with our LLM, and we'll actually play with prompt and evaluation, prompt evaluation and result. That way we'll fine tune it, not fine tune in that sense, optimize in terms of accuracy and other stuff. Here now one question: I could have used the same vector search tool as part of our AI function. So there is a AI query. I can just select search from vector search by passing the query text and index name. So AI query, AI function will give you this capability to call the SQL function as a vector search retriever tool. But AI query doesn't support the hybrid search. And for my query, I wanted to use hybrid search because the emails are tagged with customer name, customer transaction ID, customer ID in order to get better result with customer name or customer ID or transaction ID. I wanted to incorporate the keyword search. So that comes with this new hybrid search pattern, which is now supported in our vector search. So earlier it was only ANN search, but now we search both ANN plus keyword, which is hybrid.
So you are saying that this hybrid search is not supported for now through calling the AI query, because we could have
Yeah,
just do it very easily through AI query. Now you are building this vector search tool as an extra step in your agent to access this hybrid functionality that through AI query doesn't exist for now.
yeah.
Yeah, okay.
Because
AI
I
query,
was using it.
just to clarify, AI query, is it something that's available in LangGraph?
Yes,
Or
no, it's not LangGraph. It's a Databricks function, but
the
I can
Databricks
use it.
AI query function. Yeah.
Yeah,
Oh, okay. Yeah.
AI query
Got it.
function, and I can create a SQL function on top of that. Like I can create a wrapper function where I can pass the secret and scope, and I can call the vector search as part of this AI function, and that function can be added here as a function name. But here I am using this vector search retriever because I wanted to use a hybrid one because that was giving me better result.
Perfect.
Then the tool name and tool description, that's it. And you can also add filters based on your certain criteria. It's actually giving you flexibility to use a lot of other configuration parameters that way. Okay, so that once it is done, then we can just use the tool.extend here. It will be used and then it will be added in the tool set. Now the tooling part is done, then I'm creating the agent. So here is the function where I'm creating actual tool calling agent in LangGraph. And then here you can see this typical LangGraph code. Generally, if you see the customer side, you will see they will have all these functions, should continue, agent prompt, and they can also play around it. So these are normal LangGraph, LangChain code. And they can add some other stuff as per their requirement. Now here again, the new function which is I was talking about, add custom output. So through which you can pass any parameter to the output response, or you can capture the input response and you can use it. Then this is again, you can see these are the similar code which are used in LangGraph. So eventually we're not changing anything. So this is the same code will go, then workflow.compile will build the final tool, agent, node, entire workflow. And here now we are going to create our chat agent interface. So LangGraph agent, this particular is the name of the, let's say we have given this name. And here you can see we are using the chat agent flavor, which will be used in the MLflow to register this entire agent. Here there are two different function is created. One is predict, and here chat agent response. So this is this is giving us the benefit of using chat agent response in this typical format. Like it keep on getting the response, and then it will process, it will extract what is coming and all. And
Just
then there is
making sure
another
I
one.
understand, because I'm getting a bit
Sure,
confused with all the
sure.
concepts. So basically here we build a LangGraph agent. LangGraph, you can use it on Databricks or somewhere else. What we're doing here is wrap it with chat agent, which is MLflow, meaning it's open source, which is why it's not locking you in some sort of like Databricks proprietary thing with
Yes.
those custom inputs and outputs. Did I get that right? Or...
Yes,
Yeah, okay.
absolutely. Absolutely. I understand your concern. So yes, so you're not going to, use any Databricks proprietary offering or component here. It's entirely, integrated with MLflow, which is open source. And then predict stream, which is going to use the custom input, again, can be used here if you want. And then this is the messaging format, then chunking. And here again, important stuff. We are setting this entire MLflow, as you see, this agent, what we just built. This is the agent what we just built by calling the create tool calling agent function, passing the LLM tools and system prompt. And this agent is now registered in MLflow by using the set model. So set model will right now actually I'm setting the model, not yet registered. So MLflow.model.set model will set this agent, and after that we can test, and once we are happy, then we can register the model to the MLflow as a model as a code approach. Now, but right now the agent is ready. Now this agent, we can do any vibe checks, like we can do kind of unit testing, you can say. So why I need to do this? Because I need to check whether my system prompt, LangGraph, typical graph workflow is created correctly or not, or I'm getting the basic sense from this agent or not. So agent is now set, the same LangGraph is chat agent, but this agent has chat agent flavor, and we'll see how it is used in the MLflow later. Before that, we'll want to see how to test that. So for testing, it's nothing. We just call the agent and .predict function, which is created earlier. And here it's simple hello, just to see connections and all are good. And not only that, as MLflow autolog is already used, it will start logging all the trace of the agent. And this is really helpful, as Lara was talking about, like how to experiment, evaluate in an iterative process. So there, when we experiment, and even if we want to evaluate the LLM, where to look at, this is the place eventually we look at. And we'll see how the LangGraph started, then it's writing. Let me look at one meaningful message. Okay, so here I'm asking one simple question, calculate the final amount on investment, and I have given the formula. Otherwise, I have to create another function with some dynamic parameter where LLM will calculate, the LLM will take the numbers as an input and it will calculate using the function. Just to make the thing simple, I just pass the formula here, and I'm just using Python executable where it will execute the code. Once the code is executed, it will automatically give you the logs, but it's not readable, correct? But if you look at here, MLflow trace, so where we have registered, and you can say you can actually put each and every trace inside the MLflow. It is already registered using MLflow interface, and now we can see from top to different layer how the agent is interacting. So now this is the LangChain that started when user is asked question, then it's trying to write. This is the input which was given, and then
custom, this is what you were explaining before, custom inputs and outputs. So I guess this is just you're adding a JSON file.
right. This is the, so it MLflow automatically it will convert it in a JSON format for interactions. But I have just entered one single statement. I have not entered JSON. I just give it one statement. And then it will first time it will call the model. So call model is actually trying to call this particular. You can see the function. Now you can see this is the function and it's trying to call it. Now let's say I'm not getting right a response. Probably I'll go and check if the function call is correct or not. If the function call is not correct, probably I'll go back to my system prompt. I will see whether I have given the correct instruction, or I'll also see whether my function is maybe not registered properly. It's not returning any value. By default, it's moving to the next function. So there are several errors can happen. There are several way we can change the prompt to make the things correct. But first we need to check where exactly I should look at. So this is the place which will help us to do all the tracing, and it will let us evaluate the model and iterate through. Because right now, if you want to change anything, what I'll do, I'll just go back to my edges. So right now I have only one code, correct, to look at. So this is my only one code I'll look at. I'll change the, let's say, system prompt, or if I see something is happened or broken here, I want to change it here, then I'll just execute it, nothing else. Once the execution is done, I'll again come back and just execute this particular cell. I'll see the result and see whether it is corrected or not.
Okay,
And
so
that way I can run.
the notebook is for iteration. So you define your agent and then you go below and you just giving it some examples to see what are the results you get.
Exactly. You
So
can
your test.
iterate through this notebook.
Yeah. Okay.
Yeah. So this is one example. So I created two tools, correct, initially. Now I saw that my Python code is working fine. Then I wanted to test whether my RAG retriever tool is working correctly. Then I ask another question: is there any email communication from this particular customer? Let's say Steven Marshall, and let's see. I don't know to look at it. This is my way. So here I can see, correct. So first it will go here. Now you see here, it will go to this tool, but definitely it will throw error. That also I can actually rectify by writing the prompt in a proper way. But the LLM itself actually rectified the problem. It found that this is not for that particular tool. So then it will go to the next tool and it add customer. Then it actually call the next tool, which is already provided, to extract the email information from the vector search database. So it has now extracted everything and it found something. And now let's see what it's found. So it has found something here. As you see, now assistant is saying, okay, there is a subject fraudulent transaction alert sent by this particular customer. And not only that, it has found couple of them. And it has given me one. Probably I can also kind of tune the system prompt to tell the LLM, okay, report all the emails. I just ask if there is any email from the customer. So it actually extracted everything from my vector search database and it reported, just give me the highlight. Yes, there are some fraudulent transaction alerts sent by this particular customer. But based on my requirement, I can change the system prompt. So now
so
here I can
given
see.
that
Yes.
then the LLM didn't understand exactly which tool it has to go and hit, because it was going checking different tools, it was not getting answer, iterating through the next tool. So then what would be the first thing to go and check? Like if my metadata that describes the tool is well defined and maybe this is how the LLM will understand it better?
Yes, absolutely.
Mm.
So we can put a meaningful description of the function, meaningful description of different parameters which are passed to the function, and also the instructions what we are guiding prompt. So you can actually create the chain of thought kind of prompt where I can ask the LLM, let's go step by step. Okay, so if there is a question related to email, only use the email tool, do not go to the Python tool. So we have to see which language is kind of well interpreted by the LLM, and it's very interesting. Sometimes just 2-3 words and very specific instruction help to increase the accuracy a lot. I mean, sometimes definitely LLMs are quite confused which tool to call, but if we can just guide them properly, that go to this particular tool. Now we don't want to overfit again. So there is it's a very interesting exercise, and there exactly we spend a lot of time. Even customers spend a lot of time. Like we don't want to overfit the LLM with 1, 2, 3, 4 step, but we don't want to leave them without any guiding instruction also. So it's a kind of balanced system prompt will help to LLM to take a decision. So sometimes it's kind of let LLM to take decisions as per its knowledge base, but also guide with the business rules so that it's not broken. So with this technique, generally it helps a lot. But yeah, it's an iterative process. As you said, we need to check where exactly we are getting a best result. So step by step instructions. But if it is very strict instruction, in some of the queries it will say I don't know, because it will not be able to find a meaningful tool. Maybe it should go to a particular tool and using its own judgment it can create a response. But if I have given too much instruction, too many instructions, strict instruction, it will not go to that tool at all. It will stop there.
Yeah, so we have to find the right balance of how prescriptive
Yes.
have to be and specific versus
Yes.
letting it flow and be more creative.
Yeah, exactly. And this iterative process will help us to do this. Now once we are happy, then we'll go and register my agent in the Unity catalog. So this is the register tool here. As you see, all the tools are now captured here with the Databricks function, with the help of Databricks functions. So now this will be the resources. So now when we register the agent in MLflow, we have to provide all the required resources. We have to provide all the required libraries which are used by the agent, because right now everything is running on notebook, so we don't see any error. But if we don't pass all this information properly, it may break once it will run the code in the MLflow, and mostly it will break when we'll do the model serving or agent serving.
Yeah, because that is a different isolated environment, right?
Yes,
So it
exactly.
needs to have access to all the required dependencies for it to run.
Yes, yes. Yeah. So here one important here is the resources, as you see here. So in this LLM agent, one important resource is our functions toolkit, which is now sitting in Unity function in a separate function tab, and model serving will be running on a different space. So we have to tell where to get all the tools and all. And here you see we are calling the same MLflow PyFung log model, because chat model is part of PyFung interface only. So that's the reason we don't have to change the flavor in MLflow. So we can call PyFunk, but basically we'll be able to access all the different functions which are wrapped around chat agent.
Will you
And
use that regardless of what you use? Because here you use LangGraph, but if you use something else, is it the same? If you use another orchestration framework?
Yes, so PyFunk is given to wrap anything which is not supported by MLflow LangChain flavor. So if you want to build your own Python agent, and let's say using OpenAI or any Python agent, you have to use this as well. So end of the day, you have to use mlflow.pyfunk.log model. But when you will build the agent, you have to use Python function. It will not be chat agent. Or you have to see if you are building a Python agent using all the Python different libraries. If you need to use chat agent as an interfacing library, you can use, but that compatibility we have to check. That will depend what kind of libraries you are using in your open source agent framework. If those libraries are compatible, or you can use chat agent library seamlessly in your Python agent, you can use, and you can wrap using the similar method. But if you think chat agent libraries are not meaningful for you, they are not being supported by your agent framework, then you can directly use the previous way, correct? We used to use that Python function, not the chat agent, the Python function model type, pure custom Python model. Then we can call it with the Python interface. So these are custom Python function, chat agent, these all are sub interfaces under Python. So you can pick up anything which is going with your code and different libraries, and then you can wrap around it. But if something is not supported, then we have to build that particular piece of code to support output schema structure, or any kind of pre-processing and post-processing of the request and response. Because sometimes model to model, this request and response formats are varying. And there we see a lot of issues. Let's say one request is sent to one LLM, but LLM does not support that particular response format. Maybe LLM has generated the response, but our model serving is not supporting that particular format. If it's not a very standard one, then we have to build another small code to process it and put it in a standard format, what we understand. I mean, we means Databricks model serving understand. So Databricks model serving is mostly following the typical OpenAI chat response format. But sometimes in Llama, we used to get this error. So there was a function built earlier before chat agent. Now that function is not there. If you compare it with the older code, there was a stringify function was available to change this schema from one version to another version. It's a big code and quite messy, but now that code is removed by using the chat agent.
Awesome.
So then in general then, so when we are logging the agent, unless we're using an explicitly supported flavor of MLflow, which is, I guess, supports LangChain, LangGraph, some basic things, from the moment you start adding a little bit more components and different concepts, Python gives you much more flexibility. So you'll probably end up using Python in most of the cases.
Python and custom Python model, Python model instead of. So that's kind of based on the code and agent framework customer has built in or something. But high level recommendations is that whatever you want to build, you build any agent from scratch, and then wrap around Python and
Yes.
log in or log or
Yes.
register in MLflow.
Because then you have complete control of all the steps, all the
Yes.
libraries, all the prerequisites,
Yes.
and
Yes.
just wrap it the way
Yeah.
you want.
Right. Right. So you are actually building everything under this agent.py and put everything, give the path and just wrap it here. So, okay. So once MLflow part is done, then you can use your normal serving endpoint deploy. So here we have the deploy code, correct? So you can test it. And then for deployment, we are using, this is the register function versions, and this is the deployment code, agent.deploy. So we are using agents.deploy here in Databricks to create the serving endpoint. So this agent.deploy is again another new interface is created because this is created to support the integration with ReviewApp, model evaluation, and playground. Because as we know, once the model is deployed, now we can see the model here in ReviewApp. We can also see the same agent in playground. We can test it in playground, we can test it in ReviewApp, and we can also create our MLflow evaluate through the evaluation framework like this one. Yeah, this one. So these three things are part of our agent framework. So this is here is kind of our evaluation framework. When we are iterating through agent, let's say using the playground or using the notebook, the first step by if we take a step-by-step approach, the easiest way, first create a workflow of the agent and then build all the functions, register them in function or create other retriever tools. You can also use Genie as an agent as well. Then go to the playground and attach all the tool and create the template by exporting the code. So this is the easiest way you can reach out to this particular code what I was going through. You don't have to write this code from scratch, and even customer can take this benefit, and this is extremely helpful. Everything will be built in within this driver code, and after that we run it through some notebook compute and then we play around it. And here we can also create our, like this is another example with this. So like here is the evaluation. So let's say all are done. Before registering, I also want to do the MLflow evaluate. So this is my evaluation example. All the eval examples will be captured from the playground itself.
So whatever
And
test you do locally in the playground, before you export the code, so you play with the playground, you export, whatever exams you have been playing with are logged as eval examples here.
exactly. Now, these eval examples can be used to create the evaluation one, what I was showing. It was a bit
Yeah,
big
it's
one.
long.
I was playing. I was playing a lot. So now, I mean, this is kind of it will create all the requests will be captured here, and it will give me this evaluation data set, and then I can just run MLflow evaluate. Again, MLflow evaluate is that same interface which will help us, and then I can create something like this. Then and then. So this is the my evaluation screen. I can then evaluate each and every question, and I can also go and check whether a particular question is right and wrong. I can do some RCA. If I provide the expected answer, I can also see the correctness. Otherwise, it will check the different there are different metrics will be checked, like here context relevance, correctness, context semantic search, context sufficiency, grounded or not, safety part, and everything. And once evaluation is done, then we register, then it will be available in ReviewApp. So because now it's this is my model serving endpoint, which is up and running, through which my ReviewApp is an easy way you can expose your agent to your business user. They don't need to look at your code or notebook. These are all for us. But for business user, they need an quick interface where they can test the bot and give the feedback. So ReviewApp is an excellent way to expose it to your business user. Let's say as a business user, I check this, I ask some question here. Now I'm asking, give me this amount, I'm giving this amount, it calculated, and it's also giving me some reasoning, step-by-step approach, how it has calculated. You can also suppress if you don't want to show it to the user. And then let's say I'm happy, then I'll say, okay, this is a good response. And then it will also ask me, what are the different parameter on which I'm going to rate it? I says, okay, this is relevant, this is accurate. Maybe not a well structured, but yeah, it's safe, maybe helpful. Okay, then I can say done. Then all the request will be logged back to the inference table along with the request ID and the feedback, what I just submitted. Now this you can again use as an evaluation data set, and you can go back, you can change your system prompt, you can loop in back to the agent, which is going to help the LLM to improve the performance. Now same way I was using the same thing, that this customer has an email here. Now on the review app, even I got the same response, but now you can see it's giving me a nice formatted response. All the responses are coming up in a well documented format, which subject, when the mail was sent, and what was the alert. This is a withdrawal report. So it is now coming up in a nice format. And I say, okay, now this is good. And I say it's well structured, professional, probably good. Okay, some chat history is happening. Okay, done. Not only that, as you see, it's also giving us the factual information, like which email it's actually referring. If I have a doubt, I can simply go and see, oh, okay, this email is coming from this email. Okay, this guy was sent. Okay, the email is different, but yeah, I can see the same person, the person name is the same, Marshall Global Logistic, but maybe a different email. So it has extracted it correctly. So I can actually check all the emails which were extracted correctly on the same screen, and then I can share my feedback here.
Awesome. So
So
here, just taking a step back, you showed how to build a LangGraph agent, but then, as mentioned at the very beginning of the video, you can also build an OpenAI agent that's wrapped into the whole thing. Can you show us what that looks
yeah,
like
sure.
very quickly?
Sure. So let me see. So this is another way you can use the agent framework. This is another authoring pattern, you can say. Uh, all are same, only OpenAI library will be added here. So earlier we are using Databricks LangChain library. Now we are going to use OpenAI library along with the Databricks, where we are going to use the similar concept. Again, the code will be exactly same. The same agent in a code here. The chat agent, again we are going to use the Python model, the chat agent interface. Now we are going to use the OpenAI flavor. So earlier it was a Python flavor, as you said. Now the flavor has been changed here, OpenAI flavor, and some code snippet here and there it will change. Like this is the init function is now changed here. It's giving here MLflow trace, predict, chat agent interface. These are kind of similar function. Predict stream will be there. And now it's a chat agent chunk is created along with this chat agent message, and then set model. These are the similar step. There is nothing changed. And then again here you can do some, test the agent and all. These are kind of similar stuff. Only one change is there. The initial library, instead of LangChain, now we are going to use all the OpenAI libraries. And because now they also have a MLflow integration, so through which you can use the OpenAI Autolog, and instead of LangChain, if you want to use, you can use OpenAI.
Which is good because it changes so fast. Honestly, every day you have a new framework that comes up. I never know which one, is best. Opinions change very often. So it's good to be able to swap because honestly, this landscape is still changing very rapidly. So.
Yes. And there is a very nice document available on the Databricks, the same how to authoring the AI agent. And here you can see a quick difference. So LangChain, LangGraph, you just need to install Databricks LangChain, OpenAI, only the Databricks OpenAI, and it's a pure Python. Now in the pure Python agent case, Databricks is providing a Databricks AI bridge, which is nothing but an abstraction layer on top of Databricks Vector Search, Databricks Genie, and if you want to use all the Databricks typical UC function toolkit, so on top of that they have created this AI bridge, so you can use your Python agent, but still if you want to use the Databricks component, you can use them by using the Databricks AI bridge, because then it's not going to change rest of the approach what we have just seen in the LangGraph formats. Okay, definitely LangGraph will not be there. Maybe you want to use your own Python agent, you have built something, but you can use the Databricks component using all those libraries like Databricks LangChain and UC function toolkit and all.
Makes sense. I mean, from the moment that you decide to bring your agent on Databricks, you definitely need the way to interact with all the Databricks components,
Exactly.
and etc. So these libraries offer that. Whatever framework you decide to go with, then you'll have to add a layer of interacting with the Databricks components, and this is what the Databricks specific libraries do, right? So the Databricks agents and etc.
Yeah.
Now, can we do one last thing, which is to go back to the question I had before on why do we actually write this Python file, the agent, as a code file, this agent.py file. So how I see it is that In a classical ML model, what is happening into the notebook is we are actually training a model, right? So a model is created as an artifact that we are logging with MLflow. Now, what's happening here is that we are not training any model, actually. We have models available around us as model serving endpoints, and we have tools around us as tool functionality through Unity Catalog or any other tool we are using. And what this agent code just does is orchestrate how everything is going to work together. But there is no model building, nothing. The only thing we need is just this orchestrator code, which is exactly why we write it out, and exactly why this model serving endpoint is just some code that goes and hits other different things that run elsewhere.
Yeah, yeah, nice explanation. Thank you. Yes,
No
exactly.
worries.
Yeah.
As you were going through, I was like, start realizing all of this.
Yeah, yeah, absolutely. Yes. So we are all, I mean, in LLM world, we are all looking at, same thing, but with different approach. So
Yes.
every day we are learning new approaches and new way to look at the things. But yeah, we are using the same infrastructure we have to use because these all are reusable components. So using all those components, how to build something on top of that, this is what is extremely important.
Amazing. Thanks.
Thanks, Abani.
Thank you.